Welcome back to our viewers around the world. I hope you had a good break. In a minute, I will introduce our next speaker, but I wanted to remind you all that we are recording this conference in full and actually will upload all the talks to the YouTube channel on the Baha'i Chair's website. So that's an added attraction that you can go back and listen to these talks. And also for those of you who are teachers, you can use these in your courses whenever possible. So it's with great pleasure that I introduce our first afternoon speaker, Dr. Victoria Keener. She is a research fellow at the East-West Center in Hawaii and the lead principal investigator of the National Oceanic and Atmospheric Administration Pacific Regional Integrated Science and Assessment Program. She is the lead author of the Hawaii and U.S. affiliated Pacific Islands chapter of the 4th U.S. National Climate Assessment. Dr. Keener also serves as one of 5 members of the City and County of Honolulu Climate Commission, which provides science-based recommendations to the mayor and the city council. She earned a PhD in agricultural and biological engineering from the University of Florida, specializing in hydroclimatological research. Dr. Keener leads an interdisciplinary research team of social and physical scientists that aim to reduce Pacific Islands' vulnerability to climate change by translating research into actionable knowledge and working with a variety of stakeholders at the local, state, and regional level. And you can read the specifics by referring to her bio, which is online. The title of her talk today is The Role of Science Boundary Organizations in Informing Regional Decision-Making and Policy. We are really honored to have Dr. Keener with us today, and I turn the time over to you, Dr. Keener.
Thank you so much, and good afternoon, everyone. Over here it's morning in Hawaii, but I suppose this is a global talk, so actually it could be anytime, anywhere for people tuning in. And I was really pleased that this conference moved completely online with the current situation unfolding around the world and everyone having to do alternate ways to present, but at the same time, you know, this is a climate change conference, and so it's great that the organizers were really focused on how to bring people online before any of this even happened. So they're really thinking ahead and putting this together. So I will start going through this, and like the introduction said, I'll be speaking about the role of science boundary organizations in informing regional decision-making and policy in the context of my work on climate research in Hawaii and the affiliated Pacific Islands region. And that's a photo of Honolulu and downtown Waikiki that you see on the screen now. So what I'll go through very briefly is I'll go through what a science boundary organization is, so you have some context, why it's important to the global climate crisis, and why I think that it's a key component in really our effectiveness in adapting and mitigating moving forward. I'll give you a little bit more background on my research group, the Pacific RISA, and its role as a research group and across the Pacific Islands region doing applied climate research. And then I'll go through our functions as a climate science boundary organization from an evaluation, an external evaluation that was done for our group. And then I'll show how we work as a boundary organization throughout the region with 4 different examples corresponding to our functions that were defined as the different stakeholders that we work with. So that's being responsive, supportive, generative, and critical. And I'll talk about those 4 functions more, what they mean, and give some examples to go with each of them and how they really fit in. So what exactly is a climate boundary organization before we move in? So a boundary organization has been defined as an organization that has a specific interface between science and policy. There isn't a single consistent definition, and it doesn't come with a method of implementation or guidance. It's really up to an organization to interpret how they make it work as a boundary organization. To label an organization as a boundary organization works performatively. So by saying that you are working as a boundary organization, it fulfills some of the functions and you start fulfilling that role. It can help shape an organization's identity and how it sees itself. It provides legitimacy, and it can stabilize the interactions between it and organizations. So they're really a crucial link in generating credible and trusted science that is relevant to local adaptation and mitigation decisions. Some of the functions that it produces and the things that it uses to go forward is it believes in the co-production of knowledge. So that's producing science and knowledge with stakeholders and users in mind. It embraces iterative stakeholder involvement to generate what they call credible, legitimate, and salient results. Some examples of this a global example you might be familiar with is the Intergovernmental Panel on Climate Change, or the IPCC, which is considered a climate boundary organization, and then the NOAA RISAs, of which I am a part of in the Pacific RISA. So these organizations can serve as the link between researchers, community members, and policymakers that is beneficial to all the groups, and it'll be increasingly critical in our future in facilitating solutions to different aspects of the climate crisis. So in this talk, I'm going to provide examples of how my research group, the Pacific RISA, has acted as a boundary organization in the Hawaii and Pacific Island region, has been able to inform decision makers in different sectors in using data in decision making. And so really translating global climate research into relevant management and policy outcomes at local and regional scales. So a little bit first about the National RISA program and the context in which we work. So the National RISA program, it's the Regional Integrated Sciences and Assessments. And as was said before, it is a NOAA research grant. It's an interesting grant in that it's 5 years long, which is a little longer than some other research grants. It's very flexible and nimble, and its core is in the use-inspired climate research world. There are 11 competitive programs currently throughout the US, as you can see on that map. And there are some holes in the map as well. So this large area, the Great Plains, has been largely uncovered by RISAs. And then the Pacific RISA, as you can see, I'll talk about our spatial extent later, but it's Hawaii and the US affiliated islands, which are composed of the Republic of Palau, the Northern Marianas Islands, Guam, the Marshall Islands, the Federated States of Micronesia, and American Samoa. So they have different governance. Guam and American Samoa are territories, and the remaining are freely associated states. So all of the RISAs have different research foci, but their commonalities are also include a few things. So they're all interdisciplinary. They're interdisciplinary with social and physical sciences, decision research with diverse stakeholders across the board. They do co-production of climate research, and there's a continual dialogue between those researchers and end users. They create sustained relationships with the different stakeholders to build trust, and every project is framed in a decision-relevant context. The Pacific RISA is, it's a relatively small program, but we partner quite heavily across Hawaii and across the Pacific Islands region to leverage our outputs and our results. So some of our core partners in this were based at the East-West Center, but were funded by NOAA. We work closely with researchers at the University of Hawaii. Most of our PIs are researchers at the university, other departments within the university, the city and county of Honolulu, federal programs like the US Fish and Wildlife Service or the National Weather Service or the CERDIT program. So we're really highly leveraged. Again, here's our spatial extent that we work in. So this is just to give you more of an idea of really the vast area of the Pacific that we work across. And really, we are a small program, so we do have to leverage highly to be able to cover a lot of these areas. And just for your information, the green areas on this map, such as Papahanaumokuakea or the atolls, are remote islands or marine sanctuaries. So our team and the current projects that we have are kind of summarized here. Our projects are all led by teams of one or more investigator, and we work with different sets of resource managers and decision makers in different sectors across the Pacific Islands region. So our core function is really to build island resilience and freshwater resource sustainability under both climate variability and change. We do that by working on different dynamical and statistical downscaling of climate models on an island scale. That includes things like extremes, such as rainfall and storms, different impacts of those climate models, and security implications across the region. We also work in a variety of different watershed modeling. We use ecosystem services in the context of watershed modeling to put values on those different resources. We do scenario planning with stakeholders, both law and policy analysis at the state and regional and territorial level, and do also migration, climate, and human health research. We have a very interdisciplinary team of hydrologists, climatologists, geographers, economists, lawyers, legal researchers. Your next speaker is actually Maxine Burkett, who is a investigator on the grant as well. We do evaluation as well of our own program, both internal and external, and decision science. We also lead the U.S. National Climate Assessment chapter for the region, or have in the last couple iterations, and do downscaling of that to a regional assessment and build capacity across the region as well. So as I said, part of our program is evaluation based. So that means that we're always looking at what we're putting in, what we're getting out, how we're interfacing with different stakeholders, and then modifying our program to better suit the stakeholders' needs and be more productive. We came up with this action logic model, or ALM, to really look at the types of inputs, outputs, and outcomes that we're seeing over the short, medium term, and long term that we want to see, things that feed into that, and the context in which we work. This was determined or come up with internally, but we also have external evaluations that are held every year with our external evaluator, Dr. Susie Moser. And she did an anonymous survey and interviews with a selection of Pacific RISA stakeholders as one of her annual projects, and worked with us and the action logic model to develop this function of core RISA functions as defined by our stakeholders. So these are the main ways in which Susie synthesized that we as a research collective and boundary organization are useful to our stakeholders across the region from the mouths of our stakeholders as synthesized into this matrix. So these are what I'm going to talk about in our role as a boundary organization. And so the main core of the matrix is we have four main functions: being responsive, so eliciting or helping stakeholders identify their goals and resource needs, and then working with them to meet those types of needs and create different outputs to fill them. So that might be creating different types of information to fill data gaps, training to fill in a hole of capabilities in a certain place, being generative. So opening the decision space to novel ideas and approaches. So that could include identifying new policy options or implementation strategies, creating new data and models, synthesizing documents, writing reports, and ways that generate new and different conversations. The third way is being supportive. So supporting the advancement of policy and management solutions and the creation of political will. So this could be through creating forums for dialogue and gathering people together. doing public talks and education, training specific users, or connecting different stakeholder groups with each other that don't usually talk to each other. And then finally, being critical. So advancing policy and management debates by being a constructively critical, credible, and outside voice on missing or on existing or missing approaches. So this is working more directly in the policy sphere to help inform policy with science-based findings. And on the column and row headings of these functions, we have the stakeholder need being known or being unknown. So this, they might come to us not knowing what they are exactly looking for and would like us to be critical or supportive to help them define that. Or they might know their solution very well, their policy solution that they want, or they know that it's not adequate and are looking for something new. So these are the contexts in which we see ourselves, that our stakeholders see us working and are interested in working as a boundary organization. So now I'm going to go through some examples of just how we do that. Whoops. So the first one is the first function of a boundary organization we have is being responsive. And so the example I'm going to talk about is our role leading the chapter for the 4th U.S. National Climate Assessment on Hawaii and Pacific Islands, and then the downscaling of that product to be more detailed for the Pacific Islands Regional Climate Assessment, or the PIRCA. I've also listed some contacts of people that are leading these projects, and then I have our information at the end of each subsection, so you can contact us if you have more questions. So this example is really going to show how we use climate assessments at the national and regional scale to meet decision makers' requests for local, sectorally relevant climate projections and impacts at decision relevant spatial scales and sectors. So the National Climate Assessment is mandated by the United States Congress by the U.S. Global Research Act of 1990. There have been 4 total. It's supposed to happen every 4 years. So if you do the math, it doesn't quite line up, but the last 2 have been right on time and being released. And it's really a national report, so kind of an IPCC focused on the US. So looking at the key climate variables and impacts in different sectors meaningful to the United States and its industries. So there are 10 regional chapters in this version of the climate assessment. And the regional chapters were really the main course, so where most of the information was. The key messages in these cases were determined by regional risks and values, in which we linked climate trends to regional risks, and we assessed future climate change relevant to those risks. The volume 2 of the 4th National Climate Assessment, the impacts, risk, and adaptation in the United States section was, as opposed to the more technical climate science report, was released on November 23rd, 2018, which is also known as Black Friday, the day after Thanksgiving. It was released by the White House and the Office of Science and Technology Policy kind of out of the blue on that day. And there was a lot of media attention to it, kind of surrounding the fact that they might have been trying to put it on a slow news day when people wouldn't be paying attention, but media really latched onto that, and I think it got more attention instead. But some overall things about the 4th National Climate Assessment were that it's policy relevant, but not policy prescriptive. It is a government document. It places a strong emphasis on regional framing, like I said, and risk framing. For the first time in the national climate assessments, it qualifies economic impacts. It looks at international considerations as well. It assesses a range of potential impacts that can help decision makers identify risks that can be avoided or reduced. And it uses case studies of both successes and things that were not as successful that we can learn from throughout the country to provide additional context and to showcase community success stories. You can read and download the report at this link below at the bottom of the screen. It's a really nice interactive platform, and you can go chapter by chapter, download all of the figures are high resolution and public. One of the ways that we tried to make the National Climate Assessment chapter as inclusive as possible was gaining legitimacy and salience through participation of as many people as we could get to be a part of the process. We had a sectoral survey to see what people were most interested in learning about. We had 136 respondents that from all of the island jurisdictions that responded. We held 2 webinars to get input on what we should be covering and solicit experts and names of authors. We had 6 sectoral workshops on those sectors that were identified in the survey and webinars that had over 75 participants, both experts in academia, NGOs, private groups that really helped shape those key messages over 2 days. And then we had 2 town halls, one in Honolulu and one in Guam, to talk about the results and improve on the process. Over all of that, there were 11 volunteer authors that devoted their time and their expertise to shaping this. So this was, in addition, an unpaid, 5th job to their other jobs. So in all, there were over 350 people engaged in the Hawaii and Pacific Islands chapter, and we had about over 70 technical contributors listed as on the chapter, which is many more than any of the other regional chapters. And what we found is by doing this, we're able to strengthen our regional climate network. So by really embracing an inclusive process in the national climate assessment, we can build our local networks to be stronger. This feeds into our PIRCA, or our Pacific Islands Regional Climate Assessment. So the Pacific RISA leads this organization called the PIRCA, which is an umbrella organization. It's very inclusive as well, that creates a sustained assessment process to provide the most up-to-date and vetted climate knowledge and impacts by synthesizing the best research with expert input from managers and government agencies in a particular island jurisdiction. This also provides a direct pathway to communicate key adaptation needs to Washington, D.C. through our participation and leadership in the National Climate Assessment chapter for the region. So since that, we talked to stakeholders, and the National Climate Assessment chapter really lacked that detail of climate information that islands needed for doing on-the-ground planning adaptation project in different sectors. We're now working on PIRCA climate science and impact reports as a detailed new product that we can use to expand the reach of the national climate assessment findings in each jurisdiction, and to make these findings as useful as possible while expanding the network and increasing our collective voice to those in DC, since we're so very far away. We also know that climate variables translate into local impacts in ways that weren't captured in those national level reports. So regional climate networks across the Pacific help communicate and translate these climate variables onto on-the-ground impacts in different sectors. In this case, we're looking at agriculture, fisheries, and tourism. For example, during the 1998 El Nino event in the Federated States of Micronesia, we saw coconut production decrease by 20% from drought, which has impacts in food and water security in the region. The hot oceans in the El Nino caused productive fisheries in the Western Pacific to move east, while those in the Marshall Islands area moved north. These shifts in fisheries impact the livelihood and the economies of the islands. So what are the best ways to provide those early warnings to ocean managers and fishermen and those dependent economies? And how far in advance would managers need to know in order to have these contingency plans? And that's what some of these PIRCA reports are trying to ferret out from different stakeholders. Finally, in the tourism sector, for example, they can also be highly affected by El Nino. So drought caused less fresh water to flow into Jellyfish Lake in Palau, which is a very popular tourism destination, where you can swim in a freshwater lake full of jellyfish. After this drought, they experienced a die-off of the jellyfish, and it was forced to temporarily close. So if the right people had been alerted to a drought almost 10 months prior to the die-off, when we knew there was going to be a severe El Nino, could the lake have been managed in a way that allowed it to remain open? These are the kinds of questions that we want to answer. So in these PIRCA climate science summaries, we've done the sectoral impacts in a way that are broken out for each kind of manager. So we have a bunch of different headings to get it down to the level of people making decisions. So what does climate variability and change mean if you're a waters or utility manager, if you're in public health or disaster management, if you're an educator, if you work in tourism? So really breaking out those impacts at that sectoral level. Eventually, we'll hold workshops in all 6 US affiliated Pacific Island jurisdictions and Hawaii. We've already done American Samoa, Palau, and the Commonwealth of the Northern Mariana Islands and Guam, and are working on the 3rd order drafts of getting those reports out to the stakeholders, laying out the reports. We were in the middle of planning the Federated States of Micronesia and Marshall Islands workshops when travel restrictions came down. So we're still figuring out exactly how to make that work. Because there are a lot of issues with Wi-Fi in a lot of these island regions, which makes it very difficult to be inclusive if you can't be there in person. We also have a website that collects and organizes climate science findings, data for the region. These are some of the PIRCA products and the National Climate Assessment chapters. These are all highly collaborative products. They list the in-country experts that are gathered in the workshops as technical contributors. And you can go to the PIRCA.org site, and I encourage you to contact the Sustained Assessment Coordinator, Zina Gorekny. Her information is at the bottom of the screen if you wanted to find out more and be involved. The next thing we function as a boundary organization is being supportive. So that's advancing policy and management solutions and creating political will. So in this example, we supported Maui County in Hawaii in integrating climate considerations into their mandatory water use development plan update, bringing over 100 stakeholders from county, state, NGO, and private scales to develop 4 future land use scenarios and run it through both climate and water budget models. So our questions going into this were, what are the impacts of climate and land cover change on groundwater management? There are a bunch of different indicators and impacts of climate on an island scale. So indicators are technical variables like how surface air temperatures are rising, sea levels are rising, and our base flow in streams, or the groundwater component of stream flow, is decreasing. And then we have impacts from those things. For example, coastal erosion and beach loss, agricultural land loss, groundwater flooding. So what we want to know that in this case is, considering that groundwater provides about 99% of residential water in Hawaii, how can climate projections for Maui guide planning? What are the impacts on groundwater recharge, and where should our adaptation efforts be concentrated to manage impacts such as drought and flood? Across the state, we see that historical rainfall patterns, so observed changes, have shown statewide drying. So on this map, broken out with the main Hawaiian islands, areas that are in blue show it getting wetter. You see very little of that. And what you do see over the last 60 years ago, or from 1940 to 2010, excuse me, are mostly decreases in the browns and the yellows. And those areas of black hatching on the map are significantly drying. So on Maui, which is highlighted in this red box here, there's been very pronounced drying in the last 30 years, especially since 2008, the biggest drought on history. And the impacts that we're seeing are reduced water supply, increased demand, and agricultural loss. And in the windward Haleakala, which is this region, and the East Maui Mountains, are seeing extreme drying in this black hatched area. Now, the motivation for doing this was that the state and county regulations actually mandate the integration of climate, land, and water use in these 2 acts. So there was the 2012 Act 286, the Climate Change Adaptation Priority Guidelines, which encouraged state departments to integrate future climate planning into their documents. And then the county water use and development plans which are supposed to be redone every 5 to 10 years, and for the first time are supposed to integrate those climate change issues. And now our county water use utilities and agencies are already very overtaxed. And so coming to them and working with them to generate these results and help incorporate it into their plans was our main motivation. So I'm going to skip over a lot of the science and modeling that came up with these, but in the end we had 2 downscaled climate projections, one wet and one dry, and one statistical and one dynamical, that really captured the range of projected changes in island-wide rainfall. So we had these 2 climate projections. We're a little different from the US mainland in that we don't have a lot of the downscaled projections that are available, and we don't have the wide breadth of projections to encompass uncertainty. So we use what we had, and we have to do it ourselves because the federal government does not provide those. And so what we did was we used stakeholder input with those climate scenarios to develop 4 future land cover scenarios. So this is with over 100 stakeholders over the course of about a year and a half, really going back and iterating their different interests and their different futures for Maui and what they wanted to see. And so there were some main types of land covers that came out. So the future of agriculture, the future of developed land or urbanization, the future of forest, whether it was conserved more or less and whether it was alien or native, and looking at the other land uses as well. So those are things like grasslands or water bodies and wetlands. So we came up with 4 future scenarios based on their input, including a high conservation future, a business as usual current growth trajectory future, an unchecked development future where everything was built out to full intensity, and then kind of a balanced future that did high development and high conservation, realizing that those didn't have to be done in silos. This results slide shows the modeled groundwater recharge under different land cover and climates. This is just for 2017 land cover, not the scenarios, with the future wet and dry ranges in climate projection. So what you see in the top on this slide are the mean annual groundwater recharge for the dry and the wet climates, given that static 2017 land cover. And then what the bottom does, these bottom red and blue show the changes in annual groundwater recharge in millimeters. So instead of saying absolute, it's showing where they change in the future from that average condition. And that shows in the dry climate, we see greatest decreases in recharge in the West Maui Mountains, so this area. And then in the wet climate, there are increases in recharge in the wettest parts of Maui that already exist. So we do have this range of futures. And those were put into a series of publications, and we're working with the stakeholders to really figure out how all this data, which is public and can be found on this webpage, all the maps are downloadable, all the coverages and results, how those can be built into different management decisions. So these have implications for agriculture and groundwater development. Watershed planning at the upper areas where there is more uncertainty in future rainfall, the future of taro and diversified agriculture, where is the irrigation water going to come from, and the future of conservation and forests when we're seeing recharge changes both above and below the cloud zone and how those might impact different ecosystem services, not just water. And there's some information about contacts and where to find out more about these about this project. The third one I wanted to talk about was being generative. So in this case, opening the decision space to novel ideas and generating new conversations. So when we were doing existing research on climate-induced migration from the Republic of the Marshall Islands, health came up as one of the most significant variables that impacted people's to leave, and of course is very relevant to the current situation. But what we saw with these health decisions were intricately tied to climate variability and change as well. So this project looked at identifying those links and mitigating the climate and health impacts. So this project is currently in progress, so we don't have final results yet. In 2019, the new World Health Organization Regional Director of the Pacific said that climate change was one of the top 3 threats to Pacific Island health. So there are both mental and physical impacts from climate change in the islands that range from direct exposures and changes in vector-borne disease and waterborne disease to something like an injury from a natural disaster, a storm, or a flood. Also of note, the Republic of the Marshall Islands, the RMI, just received funding for a 3-year coordinator position to actually address climate change and health issues under their Ministry of Health. So some of the things that we see that are of interest in terms of health and climate are low rainfall causing drought and scarce drinking water. These result in decreased hygiene conditions in which we see more diarrheal disease, conjunctivitis, scabies, and influenza. On the other hand, when there's above average rainfall and higher sea levels, maybe during a La Nina, we see flooding and inundation, which produces injuries, but also increases in vector-borne diseases, such as malaria, dengue, ciguatera. So one of the things we wanted to know were how do climate variability and change impact migration and health outcomes in the RMI and Hawaii, which is one of the destination of Marshallese migrants. So Marshallese are experiencing these climate-related health impacts, and their healthcare systems are already under-resourced and unprepared to confront these. So the movement of people has impacts on both sending and receiving location. And can we improve health sector access to information about the impacts of climate change in RMI and increase their adaptive capacity in both sending and receiving locations for climate-induced health risks? One of the first things that we did were identify those health sector needs by talking to people and building case studies. So using case studies to build capacity for health professionals to respond to these future climate threats. That involves interviews with people in the Marshall Islands and in Hawaii of these top-level health sector decision makers, kind of the context in which we're working, and identify decisions that could benefit from climate information. We already have a mocked up climate outlook page for the Marshall Islands. If you note those dial interfaces, so this is a 6-month output page that looks at different temperature, precipitation, tropical cyclone, sea level, and ocean variables. And it gives the recent conditions and the forecast conditions in that easy to understand dial interface. So there's a need though to translate these variables into what they mean for different sectors. So we know that the forecast for sea surface temperatures might be higher, but what does that mean for health? For example, when there's less rainfall, there's drought, they institute water conservation measures, and how does that result in different GI illnesses across the island? So this is some of the information that we wanted to get at. What you see here is an overlay of a health disaster that was happening in real time as we were working with them. And so this is a story of dengue in the Marshall Islands over the last year in 2019, and an outbreak that ravaged the island at the same time as a measles outbreak and now as the COVID outbreak, which they haven't had any cases yet, thank goodness, but it is under a background of a lot of pre-existing issues. So dengue patient 0 in this case, in this story, was a passenger that traveled home to Ibai in Kwajalein, which is in the Marshall Islands, from the Federated States of Micronesia. And unknown to them, they carried a strain of dengue called dengue 3. And they were part of the island hopper, which is a flight chain, a United flight chain that goes across from Hawaii to Guam, across the Federated States of Micronesia and the Marshall Islands, and stops at all these airports. So the RMI was just coming out of a drought and had recently experienced heavy rainfall, which gave it perfect conditions to start up. So in terms of what happened after that point, dengue became a national health emergency. You can see these are two atolls in the Marshall Islands, Ibai and Majuro, the capital, and the timelines on the bottom, the x-axis, and really showing the number of dengue-like illnesses because they weren't able to test everything per week, and how that population increased despite a travel ban between the islands. The first cases in Majuro, the capital, appeared in August after first appearing on Ibai. And then the new cases increased weekly after that. And in this case, climate was really a threat multiplier. So it was not the reason that dengue was on the islands and causing problems, but it did create conditions in which it was able to spread. So some of the headlines from that area: worse than ever, ongoing dengue epidemic hammers Majuro. Huge waves and disease turned Marshall Islands into a war zone. That's language that we've heard recently as well. So how can we use climate forecasts to help mitigate this or make this more predictable or manageable? Well, what we've done so far, and again, this is just the beginning of the project, is the National Climate Change and Health Dialogue that we were able to hold at the very end of January of this year, before everything really started shutting down. And so in these climate service dialogues, we're trying to provide climate information to help individuals and organizations make climate smart decisions. So data and information are transformed into custom products for different user groups to adapt to variability and change. And these are done in workshop formats, and again, to begin the conversation. So at this point, we're working across different ministries in the RMI and with other regional stakeholders to help inform joint climate and health planning, and generating these climate and health stories, which can help guide tool development and interventions in the future. Lastly, the final project I wanted to talk about as a role in a boundary organization is our function of being critical. So in this case, we're advancing policy and management debates by being constructively critical and credible outside voice. So through the RISA's work with city and state agencies, as well as NGO and private stakeholders, I was appointed to sit on the city's Climate Change Commission in 2018, giving our science a very uniquely direct path to informing climate adaptation and mitigation policy at the island scale by advising the mayor and city council. The regional results from the NCA should be and are being used to empower cities and states to act across the US when there is really a lack of federal leadership. So the National Climate Assessment Report is considered a federal highly impactful scientific assessment, or HISA report, which is the highest level of scientific assessment that comes out of the federal government. Excuse me. This is the official climate assessment from the current administration, approved by 13 federal agencies and the White House Office of Science and Technology Policy. So 3 days after release of the chapter, excuse me, the mayor of Honolulu held a press conference on the waterfront with 2 chapter authors to talk about climate impacts on the island and decisions that would have to be made, like coastal retreat versus hardening in economic critical areas like Waikiki. 2 days after that, the state introduced the idea of putting a price on carbon and cited the executive summary of the chapter. And there were dozens of bills at the state level last year and this year that address mitigation and adaptation to climate impacts and do build on a lot of these findings. So the debate we should be really having now is how best to counter these impacts, not whether they exist. And these chapters help do that. The Climate Commission came about through a application of the city to the 100 Resilient Cities Network. Honolulu was selected in the last round, the 3rd round of cities in the Rockefeller Foundation 100 Resilient Cities Network in 2016. And by city charter, after that was won, the Office of Climate Change, Sustainability, and Resiliency was established with overwhelming approval by Oahu voters. So what this did was it identified potential climate impacts on city facilities, coordinated climate actions across those departments, helps develop resilient infrastructure, and helps integrate sustainable values into city plans and policies. It also created the Climate Change Commission in that charter. The Climate Change Commission gathers the latest science and information on climate change impacts and advises the CCSR, the mayor, the city council, and the executive departments about future climate scenarios as they are relevant to current and future planning and policy. So there are 5 members that are appointed for 5 years, and we have expertise in energy policy, hydrology, sea level rise, green design, and ecology and adaptation. We have an advisory role only, so we have no policy-making ability. We inform. This has also led to the development of the Oahu Resilience Strategy, or the OLA Oahu Resilience Strategy, which was released in the end of 2019. There are 4 areas in which this strategy concentrates and 44 actions that were identified through working with thousands of stakeholders across the island. And those are long-term affordability, resilience in the face of natural disasters, climate change adaptation and mitigation, and leveraging the leadership of communities. Some of those actions that are within each of those areas include things like that are simple or sound as simple as updating building codes and energy codes, updating design guidelines. Honolulu has some of the oldest building codes and energy codes across all the states at this moment. And it's really hard to get those updated. Before I started working with the city, I had no idea that things like this were as hard to get advanced. Specifically in climate change adaptation area, things like shoreline management, stormwater management, and reduction of flood risk. And I encourage you to go look at that resilience strategy that was developed. It's very nice and has a lot of different ideas in there. So as working at the Climate Commission since February 2018, we've had over 24 meetings. We've had testimony and discussions with all sorts of departments across the city. That includes things like emergency management, the Board of Water Supply, facility maintenance, the State Insurance Commission. And we've been able to coordinate across these different departments. Some of the things we've produced are recommendations for sea level rise management, and modifying island-wide shoreline setbacks, and we're working on equity and financial risk papers at the moment. Finally, I'll just go back to kind of the thesis of this talk about climate boundary organizations being critical to transform global science into local implementation by creating this productive interface area between science and policy. Going through those four functions, those 4 major functions that our external evaluator went through to really identify areas in which we were working, being responsive, generative, supportive, and critical. And I'll leave the group with the idea that by embracing the principles of working with boundary organizations, we can increase our sectoral climate resilience and equitable adaptation policies in the global climate crisis going forward. Thank you. And I guess.
Thank you, Dr. Keener. I really enjoyed hearing what you had to tell us about a region of the world that we don't often hear about. And particularly at this time with our policy on isolation, it's hard to look at those slides of the gorgeous beaches in Hawaii. But I'm going to turn it over to Dr. Seaman for the question and answer session. Thank you.
Thank you.
Thank you very much, Dr. Keener. So as we have been doing all day, there is a question and answer box on the right-hand side that attendees can pop questions into, and then I will read those out so we can have a moderated question and answer session. So I will give people some time to pop questions into that box. And then one of the things I had a question about was you talked about the connection between climate change and health. And I think that's something that's very much come to the forefront with the recent crisis, and thinking through what can be done to mitigate some of those effects, and how can we ensure that communities are resilient both to climate change risks, but also the kind of connected risks as well.
Right, and I think part of, it's a great question, and we have been trying to put together resources that kind of look at how the climate crisis is relevant to the coronavirus crisis as it's going forward, and looking at these as, these are threat multipliers that are all just making things more complicated and worse in many ways. So on our Pacific RISA page, we have put together a lot of resources for people that are coming, articles that have been written, and initial looks at kind of thinking about climate crisis and public health and coronavirus at the same time, and lessons that can be learned from it. But yeah, really those, this kind of boundary organization framework can really help overlap disciplines in a way, I think, that can make these conversations easier and get science into the hands of decision makers on the ground that are looking to improve the situation.
Thank you very much. So the question box is open if anybody has questions, or I think actually Hoda might have a question.
I have a question, and I know a question just came up, but my question is this: the model you have presented is really quite marvelous and remarkable. In your opinion, how are the leaders in these communities or nations responding to the science of climate change?
Yeah, that's a great question. And of course, the context in which we work it's going to differ for everybody on your region and your governance structure. And we're very lucky in that the Pacific Islands region and Hawaii are, when it comes to the climate conversation, everyone is very aware of the threat that it presents and are very active in trying to get as ahead of the curve as they can in adapting and mitigating, because in many senses, these are places that are experiencing very severe climate impacts and have contributed very little to the problem. So they realize in many cases that they are going to have to get out of this themselves in a lot of different ways and have to increase their resiliency as much as they can before a lot of these impacts, the worst of these impacts occur. So yeah, we're very lucky to work in a region that is open to working with us and open to science.
So we have a audience. So the question is, since El Nino is a recurring or reoccurring phenomenon, have the findings you presented been utilized to help the populations affected by the phenomenon anticipate the next one? So how are you kind of projecting in the future?
Yeah, so the El Nino is a recurring phenomena, and one of the strongest impacts that it has in the Pacific region is the drought that it brings to the Western Pacific. And we do have the ability in experimental El Nino forecast to get about a 6 to 9 month lead time. So every time we do see the model showing that a El Nino might be developing, it has been up to us and a lot of other regional organizations to work with the meteorologists in charge in these different jurisdictions, as well as the different departments in the governments to get out this information. And so a lot of what this looks like is, well, for example, there's one group called the PIAC that is run through the U.S. National Weather Service, the Pacific ENSO Applications and Climate Center, PEAC. And their job is to do exactly this. So to get these experimental forecasts, to get them out to agricultural extension specialists, to Sea Grant, to people who are working on the ground with people where they can really become that trusted messenger and help get the information to those who could use it. So some of the early successes of that group were in the 1997-1998 El Nino, where the PIAC went around, and we have case studies on this, and talked to all of and at the time it was incredibly rainy. So they were forecasting these horrible drought conditions in 6 months while rain was beating down all around them, warning that they would be dealing with this. And we're able to avoid a lot of the worst health impacts by putting up billboards about drought coming and things like that.
Thank you. So we have a few minutes left. We still have time for questions. While I give people a chance, I had another follow-up question which builds on what you were just saying and comes back to your talk where you're talking about this co-production of knowledge between the researchers and the end users. And I was wondering how you go about building trust between these different groups, between policymakers and then the end users, the stakeholders, and then also the researchers.
Yeah, thanks for that question. So the building of trust is really one of the most important things that you can do to get your science used. And there's been so much social science done on how to best build that, how to best include stakeholders, make them part of the process, help with designing the research and the products. And one of the best recent studies that I've seen was looking at the different factors that helped get science and data actually used in management. And one of the factors that had the highest success rate was intensity of interaction. And so that is repeated interactions over a length of time. And it doesn't even have to be about the science, it's just getting to know the people that you're working with and building a relationship with them, checking in. These are things that aren't usually prized in technical climate science or basic science of going out and talking to people and creating relationships. But in this study and in others, that sustained relationship, which can be very hard to do and time consuming, is one of the most effective ways of getting science and data into management.
Thank you. And you had a question?
No, Kate.
Oh, sorry, I saw you pop in. So we have 3 minutes left if anybody in the audience has any more questions they would like to ask.
Okay, since there's nobody asking questions, I do have one more, if I may. I was wondering if this model is being replicated in other places?
Yeah, so there are, and I'm most familiar with United States systems that are replicating this type of model. And at the governmental or federal level, there are institutions like the Department of Interior Climate Adaptation Science Centers, the CASCs, that are embracing this co-production model, working for things like national parks. And then there's also, there was the landscape coordination cooperatives, or the LCCs, that were defunded by the federal government last year. But there are these federal agencies that do embrace this type of model, including the RISAs. And of course, a lot of the adaptation community, climate adaptation community, does also work very closely with different community groups.
Great, thank you. We have a question from the audience. How do you deal with organizations that perhaps want to see increased climate change? Do you come across those?
Meaning an organization that is working for like increased fossil fuel emissions, or
I think so.
Yeah, so we're lucky in our region that we don't really have to deal with many organizations like that. But I have worked, when I was in Florida on my PhD, working with both government and private groups that I don't know if they wanted to see increased climate change, but let's call them skeptical of the science. And in that case, bringing working with people in the context by which they make decisions is always a good start. So talking to people and finding common ground. If you're talking to farmers who are skeptical about global climate change, finding out about droughts that they might have experienced in their history and talking through impacts of drought and recurrence of drought or recurrence of flooding, and looking at how that's impacted them. And soon, when you're laying out a timeline of how these different climate impacts have affected them and their personal economies, a lot of times you see you're talking about climate change anyway, and you just never have to say the words.
That's great. Thank you very much. So I think we're out of time. So I wanted to thank Dr. Keener again for joining us today and for your very, very insightful presentation. And yeah, thank you very much. We'll be moving on to our next presenter, and Hoda will be introducing her, but I wanted to take the time to thank you again.
Thank you.